In this video, we take a look at the process of database normalisation from zero normal form up to third normal form. Most large computer programs make use of a relational database in some way. A relational database takes a series of separate, disconnected flat file tables and creates relationships between them. We have looked at this concept already. Here in this example, we have two tables which are joined by this relationship. We can say from this that many students can belong to a tutor group, or that one tutor group can contain many students. We have also discussed the importance of identifying a field in each database table which must be able to uniquely identify each record. If we look at this table of students, which of these fields could be our primary key? The answer is none. We can't guarantee that any field in this table won't be duplicated when new entries are added. In this circumstance, we simply add our own unique primary key, in this case, student ID. That was just a quick recap. Let's turn our attention now to focus on this video, normalisation. The aim of database normalisation is to make a database more efficient by removing as much redundant and unnecessary repeating data as possible. Study this table, for example. The data stored in these last three fields is being repeated a lot. If this table was to grow to include 30 students in each tutor group, the tutor and the room field would end up being needlessly repeated. This takes up storage. It makes much more sense to split the table based on the tutor group field and create a relationship between the two tables. In this circumstance, the field you choose to split on becomes the primary key of the new table and remains in the original table as the foreign key linking field in order to form the relationship. There are lots of ways of arranging data in tables within a database, and each arrangement can be given a label according to how it's been arranged. These labels are called normal forms. There are many normal forms, but for A-level, you need to be aware of first, second and third normal form. The concept of splitting up tables in a database and arranging the data to move it from first to third normal form is called the process of normalisation. Let's start by looking at this table of students. This table is not normalised at all. We can think of it as being in zero normal form. To get this table into first normal form, we must eliminate any duplicate columns from the table, create separate tables for each group of related data, identify a column or a combination of columns that will uniquely identify each record in the table, therefore choose a primary key, and remove multiple values in any single field. That last one is quite important, and it's likely to be a first step you require to spot in an exam for moving a table into first normal form. Here we can see we have multiple values in a single field, so this can't be in 0NF. Here's another example in 0NF. The last point is saying that the attributes or data items in a relation must not themselves be sets, so we can't have multiple values for one tuple or record as we do here. So going back to our original example, here we now have our database in first normal form. We've split up the data in the lecturer column into lecturer initials and lecturer name, and we've added a primary key called student number. To get the database into second normal form, we must check the data is already in first normal form, remove any data sets that occur in multiple rows and transfer them to new tables, and create relationships between these new tables and earlier tables by adding primary foreign key links. Here you can see we've split the table on course number. Course number automatically becomes the primary key in the new table, and also remains in the original table as a foreign key. This has removed all the repeating redundant data which was occurring on course information, but it's introduced a problem. Now a student can only take a single course. We want a situation where many students are able to take a course, and a course can be taken by many students. We've just identified there's a need for a many-to-many relationship between these two tables. This is very important to spot in exams, as many-to-many relationships are not allowed. To solve this and get the database into second normal form, we must create a linking table and flip these many-many relationships into two one-to-many relationships. This is very easy to do once you spot it. You simply take the primary key field in each of the tables and put those together in the new linking table. Together, these become a concatenated primary key in this new table. The primary keys remain as foreign key links in the original tables. Now a student is able to take as many courses as they like via this new table. The final step is to get this database into third normal form. To do this, we have to check the data is in second normal form and remove any columns not dependent on the primary key. Make sure you understand this last point. It means that every non-key field must depend on the key, the whole key, and nothing but the key. In this example, the course F451 is the computing course. But that doesn't mean that it has to be lectured by Craig Sargent. The lecturer could easily change, a new one could be appointed. So we can infer that the lecturer and his details are not fully dependent on the key course number. We simply break this out into a new table as before. Here we finally see the database and its related tables in third normal form.